Alright, so this problem says to find the particular solution that satisfies the differential equation and the initial condition. So we have f prime of s equals 12s minus 12s cubed. And our initial condition is that f of 3 equals 5. Now that doesn't mean f prime of 3 equals 5. That means f of 3 equals 5. And to kind of understand what they're talking about, well, we have a function. They're giving us a function f prime of s. But if we take the integral of f prime of s, the indefinite integral, so we have no bounds of our integral, then we get the prime disappears and we get f of s plus c. So what they really want us to do right now is we're solving for this c right here, this constant. What is this constant? Well, first we're going to have to take the integral of f prime of s, and we have f prime of s equals 12s minus 12s cubed. Now we take the integral of both sides, and really you don't even need it. We know what this is going to be. That's just going to be f of s. So let's take the integral of this side. We'll do both just so you can see. F of s. Now we're in a different function. This isn't the same as f prime of s. F of s equals the integral of 12s minus 12s cubed. Make sure I'm writing that. Yep, 12s minus 12s cubed. So one thing you can do, and you're probably going to see Professor Toma do, is before she deals with this, she's going to pull out, you can see there's a 12 multiplying your s and a 12 multiplying your s cubed. So she's going to pull out this 12. Then you have an integral of s minus s cubed. So where we go from here is just how we evaluated the other integral. So we have s goes to, we don't need our integral sign anymore because we're doing that now. S goes to s squared over 2 plus 1, whatever this is, this value here, plus 1 over that value plus 1. So s squared over 2 minus s3 plus 1 is s to the 4 over 3 plus 1, which is 4. But since we didn't have any bounds on our integral, we have an indefinite integral. So now we get our c that we're going to be solving for here in a second. But first, let's distribute the 12 back in there. Let's distribute the 12 back in there. Actually, no. Let's leave the 12 out. And what we'll do is we have a 12. We'll go ahead and make them have common denominators. So in order to make the 2 here a 4 here, or 4 like this one, we just got to multiply the top and bottom by 2. So now we get 2s squared over 4 minus, and you'll see why I'm doing this in a second, s to the 4 over 4 plus c. Now we can pull out a 1/4. Now we can pull out a 1/4, and we get 12 over 4 times 2s squared minus s to the 4th plus c. And this is just going to be 3, so we get 3 times 2s squared minus s to the 4th plus c. And this is our f of x, not f prime of x, this is our f of x. Okay, so now we're here. What do we do next? Well, remember we got to solve for c, and they gave us initial conditions to do that. They gave us that f of 3 equals 5. F of 3 equals 5, and I'll write that down here. F of 3 equals 5. What is that saying? That's saying that when x is equal to 3, the whole function equals 5. When f is equal to 3, the whole function is equal to 5. So let's see what that looks like. F of 3 equals, let's plug our 3 in for all our s's, not x, s's. S, sorry. F of 3 equals 3 times 2, 3 squared minus 3 to the 4th plus c, which equals 5. Because when x equals 3, the whole function equals 5. Well, now we just got to simplify all these terms, and we see we only have one unknown, which is c. So now we have 3 times 3 is 9, times 2 is 18, minus 3 to the 4th, 3 times 3 is 9, times 3 is 27, 81, plus c equals 5, and 3, 18 plus 3, 63, 73, 63. Negative 63 plus c equals 5. And I'm not even going to be able to calculator time. 3 times negative 63. So we have negative 189 plus c equals 5. Well, now just to solve for c, we add 189 on both sides, so we get c equals 189 plus 5. c equals 194. And we're not done yet because it asks, find the solution that satisfies the differential equation and the initial condition. So they want us to find the whole function of f. So the solution, let's find solution let's see if I can copy this. Our solution so this is our solution, but we don't know our c value in this one, but now we do. So our solution is f of s equals 3 2s squared minus s to the 4th plus our c we know now is 194. Our c now is 194. So this is the solution to our problem. This is the solution to our problem. And it's one of those things that if you don't know for sure, or if you're second guessing yourself, what was our initial condition? Our initial condition was f of 3 equals 5. So plug in 3 for your s's here. So you plug in 3 here, and then set it equal to 5, and you would check that you wouldn't even have to set it to equal to 5. You just plug in 3 here and make sure that everything on this side of the equation equals 5 when added together.